Hi everyone, this is the Unit 9 review sheet, and get your calculator out because you're going to use it right now. So number 1 says to graph each function. There's a whole bunch of questions to answer, like vertex, max or min, X-intercepts, roots of the equations, and the axis of symmetry. What the axis of symmetry is, we'll go through, and you have to graph each function. So I did put it in my calculator, and I'm going to press graph, and I see that. And that's what I put on this graph right here. Remember to graph it, though, second function table, and you will see a list of values that you should graph. Remember, the vertex is going to be at this point, since this is facing down, it is going to be up here, and this is the highest point, which is a max. So you can put down that the vertex is a max right now. To get the exact vertex, you press second function and trace, hopefully. And since it's a max, and hopefully you remember that, and number 4 is your maximum. All right, it'll say this. It'll say left bound, and you move that cursor over to the left, and then you'll say right. It'll say right bound after you press enter, and then you press enter again. You're moving the cursor over to the right, and then it says guess. I like to put it right here. It makes sense, and that is the vertex, which is -1, 9. So you can put that down as the vertex, and you could also put down that it is a max right here. X-intercepts and the roots of the equation are the same thing, but let's go over how you would get that. It does look like the x-intercept is -4, 0 and 2, 0. It does look like that, but press second function and trace, and you will see the x-intercepts are the zeros, right? The roots are the zeros. It's the same thing. So I'm going to press 2. And I'm going to move this over, the cursor, left bound, before it crosses the x-intercept for the first time, and then right bound. Going to move it up a little bit, press enter again, and then the guess would be somewhere right about there. Press enter, and you get -4, 0. All right, that is the first time it crosses the x-axis. I'm going to try to do it again on the other side now, pressing 2 for 0, and I'm going to go and move this cursor all the way over to the left hand side, pressing enter, and then move it to the right hand side after the intersection point, press enter, and then guess it would be right about there, and it is perfect, 2, 0. All right, so I put down as the x-intercepts -4, 0 and 2, 0. Or you could put x equals -4, x equals 2. It's the same thing. And then the roots, it's the same. X equals -4 or x equals -2. Same thing. All right, and that's it. The axis of symmetry is this line right here. It is the midpoint up to where you could draw that line, and it acts as a mirror on either side. You could fold that parabola up on that line, and it would be the exact same thing on both sides. So it always, right now, like always, is where the vertex, the x of the vertex, is the axis of symmetry. So this line right here is what we're talking about, and it's x equals -1, that line right there. All right, so x equals -1 is the axis of symmetry. There is an axis of symmetry formula. The formula is x equals -b over 2a. I used it over here. The -b, notice it's already negative, the b. So if I substitute a negative of a negative in, it becomes positive. All right, and 2 times a is 2 times -1, so it becomes 2 over -2, which is x equals -1, and that's it. All right, x equals -1. Go ahead, try number 2. Remember, graph it in your graphing calculator. Bring up the graphing calculator, graph it. just make sure that you are putting the right equation in there, a right quadratic in. Remember, this quadratic is negative x squared plus 2x plus 2. And if you press graph, you could see exactly what I see right here, and I graphed it. Remember, press second function and table and graph to get some of the coordinates down. And I would start with -2, comma, -6, graphing it until it can't fit. So on the other side, 5, 4, -6 is the last point that you could possibly graph on that calculator. So the first question is asking for the vertex. So I am just going to go to the graph one more time, and then second function trace, which will give you the calculate screen. Since we're talking about another parabola that is facing down, the vertex is on the top, right? And that's a maximum. So I'm going to press 4. And I'm going to say, all right, see, this is left bound right about there. I'm going to position that cursor, and then I'm going to position the cursor right about here, right bound, pressing enter, and I am going to press guess. Is 1, 3. So put that vertex down as 1, 3. All right. So it is a max on the vertex. Is it wider or narrower than x squared? So I'm just going to put, since it's a negative x squared, I'm going to put negative x. I'll just graph x squared. I just don't want you to get confused. It is x squared. Is it narrower, wider, or neither? It is neither, because remember, the coefficient is basically the same. All right, so if the coefficient is 1 and -1, it's going to be the same width. All right, so it is neither. If the coefficient was different, then you would say, all right, okay, it's different. So if you have like a, say, like a y equals 5x squared, and you press graph, you notice it's narrower. So the further away the coefficient gets from 0, the narrower the parabola becomes. Right? The closer to 0, the wider. Right? So if it's the same coefficient, or the positive or negative, it's the same width. Like this one was +1 and -1. And that's it. So I'm going to clear out, though, because I have something else to do to figure out, and I don't need to see 3 graphs. I just need to see this original graph. Right. So I'm just going to get they're asking me about the domains. So the domain, just remember, is the value of all x's. So just keep on going like this. Okay. The x's. This goes to the left forever. This goes to the right forever. So the only thing that you could say is that all x's count, all of the numbers, right? So it's all real numbers. So that's what you have to put down, all real numbers for the domain. The range is the y. It's the y. So the y starts as -3. Starts as +3 and goes down forever, because the y's will always be covered from this point to that point right there, and down and further and further and off the screen. So we have x is less than or equal to 3. Right? You're starting at 3 and going down all the way. Right? Let's take a look at those x-intercepts, those zeros. So I'm going to press second function and trace and press 0. All right, so let's see, because these are not whole numbers, very difficult to do any other way. You press left bound, press enter. Move it to the right, press enter. And then a guess, which is right about there, press enter one more time, you get negative 0.73. Negative 0.73 is one of the x-intercepts. Hopefully you did that. Hopefully you'll be able to do that. You have second function now. We're going to do it again for the right-hand side of the parabola where it crosses that x-intercept the second time. We're going to press second function trace and then 2 again. And I'm going to move this cursor left, right, that's right. And I'm going to say, all right, I'm going to stop there. That is left bound. I'm going to press enter. And then right bound is right about there. I'm going to press enter. And then a guess is right about there. Press enter. It is 2.73. Round it to the nearest hundredth. Right? So that is it. The axis of symmetry is that x equals 1. And that's about it. X equals 1 for the axis of symmetry. All right, and that is that for number 2. Hopefully that helped you out. All right, without graphing the quadratic function, complete the requested information. Without graphing. So we are not going to graph, but, and you could just answer these questions based on what you know. Do you see this number right here? It is a 2. It's positive. So remember, if it's positive, that means this parabola should be facing up. And that vertex will be a min. So that's what you should put down. Now, knowing what you know, what I just said about the x squared and the 2x squared, would it be narrower, wider, or neither? Narrower, wider, or neither? This number is a 2. This is a 1. Remember, the closer to 0. And the other one. And the further away, the closer to 0, the wider it is. The further away, the narrower. Like it gets narrow. So this should be narrow. I know it says not to graph it, but we are going to use that graphing calculator. And obviously we're not going to graph it. But always use the graphing calculator, even if you don't have to graph it. It's 2x squared plus 9x minus 3. And we're going to graph it. And you could tell that that is a parabola that is opening up and it has a min. Now, is that wider or narrower than x squared? If you know your stuff, you're going to say narrower. That's the x squared. You see how the x squared is? And this is narrower because that coefficient is further away from 0. Just easy way to use the calculator. Number 4, do the same thing. See if you can do it on your own though. Use the calculator. All right, use it. And that's it. We'll go through it together. Press pause now. So, by the way, remember press alpha X for that that shortcut to the fraction symbol there to put it into the calculator. I have negative 2 over 3x squared plus 2x minus 5. Even without graphing this, though, I'm going to press graph next. But even without graphing this, I told you that anytime you have a negative coefficient in front of the x squared, that is going to give you a parabola that is facing down. And that is going to be a max. And this is the parent function of y equals x squared. And you know that the closer the coefficient is to 0, the wider it is going to get. And in this one is -2/3, so it's definitely going to be wider. That's what it says, that you really don't need your calculator for this, but you should always check using the calculator. So I am going to bring this up, and I am going to graph. The first one is going to be the one that we have, and then the second one is going to be the parent function in red. So this is wider than the parent function, just a little bit wider. All right, because that is just a little bit closer to 0. It's -2/3, and that is number 4. So number 5 and 6, solve for the variables using the square root function. So the square root method. So factor first, remember, go through all of it and show your work. Remember, show your work. So we'll do this one together, and then you guys could take number 6. So when we're talking about solving for the variables using the square roots, it has x squared, right? So we have we have this 5x minus 1 squared. The only way to undo that is the opposite, square root both sides. When you square root both sides, the squared goes away. It's like doing opposite inverse operation. So you have 5x minus 1, and you're going to take the square root of 12. And since it's the square root of 12, it's plus minus. I just wanted to make sure that you knew that. So you take the square root on both sides, and just like I did over here, and I have 5x minus 1 plus or minus the square root of 12. I took the square, I used the calculator, I have square root of 12. In my calculator, I got 3.46, rounding to the nearest hundredth. So now I am ready to solve each one of these, splitting up adding 1 on both sides, and I am going to grab my calculator one more time to figure out what is going on. So on this side, I added 1 on both sides. I have 5x equals 4.46. Always rounded to the nearest hundredth. Divide by 5, and you get x equals 0.892. And I'm going to round that to 0.89. And for that last one, you have this plus 1 on both sides. You have 5x equals negative 2.46. You divide by 5, and you get x equals negative 0.492. I rounded it to the nearest hundredth, negative 0.49. So those are the roots. And we're going to go to number 6. Go ahead, see if you could work this out. Remember, you're solving using that square root method. So just to help you along here, remember when you're using that square root method, you need to get this 25. You need to have all of the variables over on one side, on the left side, and you need to do this first. Remember, you have to subtract that 25 and subtract that 25. And that's the first move. And then you would square root both sides and see where it leads you. Okay, so we have this, x squared plus 10x equals 96. Remember, at that point, you're going to take 10, which is the b, and divide it by 2. 10 divided by 2, and that equals 5. Then you take 5 and you square it. And that equals 25. And you have to add now 25 to both of these sides. This is creating that perfect square. It's helping you use this method. All right. So we have x squared plus 10x plus 25 equals 96 plus 25. You end up getting like the same thing as what you started with, which is really confusing. But now you could go ahead and factor this trinomial. So remember, when you factor at this point, the binomial you're gonna get is the same binomial. The two binomials that you get are going to be the same binomial. So this is all positive. What times what equals 25. Two numbers equal 25, and then add to 10. And obviously that is 5 times 5. So you have x plus 5 squared equals 121, because x plus 5 times x plus 5 equals this. All right, so what you do right now is to square root both sides. And that's pretty good, because you need to get that out of there. That is now x plus 5. And the square root of 121, there it is 11. And it's plus or minus 11, because remember, every single square root has two answers, one positive and one negative. We set up the nice two equations here. When I say nice, there's nothing to actually round, or there are no decimals here. It's nice and all whole numbers, so it makes it a lot easier to figure out. So this cancels, and you have x equals 6, and this cancels out, and you get x equals negative 16. Those are your two roots. You put an or, and that is it. Solving using the square root method. Oh, that's fun. It's good. All right, so for these two problems right here, let me move my face over to the right side. We have to solve. It says, all right, so it does say here that for 7 and 8, quadratic function graph is shown. Identify the solutions or roots of the related quadratic equation. So it does not say that you have to show work, and you could just really just look at what this is right here, what the roots are. So I am going to put a point right here and put a point right here. Those are the roots. That's it. X equals negative 1. X equals 2. Nothing else to do. That's it. Take it. This is these are easy questions. No work shown. Just put your points on those 0 and 3. And that's it. Numbers 7 and 8. Done. Okay, solve by completing the square. Leave in simplified radical form. So, remember, really important to just take this and bring it over. Take that C, if there is one, and bring it over. And once you do, you add 17 to both sides, and once you do, you get x squared minus 2x equals 17. So now you take the b, which is negative 2, and divide it. All right, remember, divide it by 2, and you get negative 1. All right, and then you take that negative 1 and square it, which is positive 1 now. Then you add it on both sides. That's right. So you're going to end up like x squared minus 2x plus 1 equals 17 plus 1, which is 18. Now, your job is to factor this. Remember, you're going to have, hopefully, two binomials that multiply together that equal 1 and that multiply to negative 2. So if you're saying negative 1 times negative 1 equals positive 1, and negative 1 plus negative 1 equals negative 2, that is correct. So you should have x minus 1 times x minus 1, which in this case is just squared, equals 18. All right. X minus 1 times x minus 1. And remember, you just go ahead and square root both sides. Because you need the opposite. You need to use the opposite, the inverse operation of something squared. So I'm going to bring my calculator up, and I am going to get the square root of 18. And I'm going to round that, because that's not a perfect square. So you have 4.24, and it's plus or minus 4.24. All right. Split up the equations just like this, and you solve each one. Remember, adding 1 on this side, adding 1 on this side. Adding 1 on this side, adding 1 on this side. Cancels, cancels. And hopefully you got x equals 5.24. And this one equals x equals, you could always check this in the calculator, negative 3.24. When you graph this, it should be exactly what this is. I'm not going to do that right now, but you can graph it and see, if you're correct. And that's it. All right, number 10, see if you could do this on your own. Again, completing the square, follow steps, and take it on your own. Press pause now. So, hopefully you didn't go through. All right, so you had plus 13. There's a little bit of a trick. This is a tricky question. Plus 13 on both sides, and then you have 2x squared minus 8x equals 20. This coefficient in front of the x squared must be 1. So I am going to factor out a half, and when I get that, I could use this right here. Remember, this must be 1 for this completing the square method to work. So when you factor out a half, half of 2 is 1. Half of 8 is negative 4. And half of 20 is 10. So now this is your new equation. Now you could go ahead and you could take the b and divide it by 2. So just erase what you had if you did do it incorrectly. You have negative 2, and then negative 2 squared is 4. Right? So now you have x squared minus 4x plus 4 equals 14, which is 10 plus 4. We are now ready to go. You have x squared minus 4x plus 4 equals 14. So you're looking for binomial that multiplied together equals 4, obviously, and the positive 4 and adds to a negative 4. So it's negative 2 times negative 2, and I am going to put that as x minus 2 squared. equals 14. X minus 2 times x minus 2 is the factored form of x squared minus 4x plus 4. Now we go ahead and square root both sides, just like that. Square root of 14, not a perfect square, is 3.74. All right. And we have x minus 2 equals positive negative 3.74. I split them up over here, and I'm going to add 2 to both sides. And this side right over here becomes x equals 5.74. And this side over here, I'm going to put an or. And this adding 2 to a negative 3.74 will equal x equals negative 1.74. Just to show you have x you can show it this way, the answer. X minus 2 equals plus or minus square root of 14, and you add 2 to both sides. And instead of taking the square root of 14 like I am doing right here and rounding it, they sometimes show it to you like this, which is x equals 2 plus or minus the square root of 14. Either way that you do it, it says leave in simplified radical form, so I guess this is the best way. It's not saying to round. So if it says to leave in simplified radical form, it would be x equals 2 plus or minus square root of 14 as the answer. All right, or you could do it this way if it says to round. Going back to number 9, just to make sure you know, I am rounding them. Right? If this says leave in simplified radical form, which I just did see, it is this answer right here. Right? So this is simplified radical form. And so you have right here 1 plus or minus square root of 18. That's what I was doing right here. And that is not simplified radical form like I just said. Square root of 18 can be broken up into a perfect square and a non. 9 times 2, which is 18, and the square root of 9 is a perfect square. So that would come out as 3, radical 2. So the final answer in simplified radical form would be x equals 1 plus or minus 3 square root of 2. Yeah. So this part right here would be rounding to the nearest hundredth. This part here would be doing what the directions said, leave in simplified radical form. And I'm just putting it into yellow right here. This is the simplified radical form. Whenever you have a square root of 18, you're looking square root of a number. You're looking for a number, two factors, that one is a perfect square, one is a non. All right. So non-perfect perfect square is 9 times 2 is a non-perfect square. You split up the square root radicals, and square root of 9 is 3. That's where this 3 is coming from, and the square root of 2 comes out. So it's x equals 1 plus or minus 3 square root of 2. And that's it. All right, so I'm going to do the same thing over here. All right. So this right here, 2 plus or minus square root of 14, we're looking for two factors that multiply to 14, that one is a perfect square and one is a non. We cannot find that. 7 and 2, they just don't work. So this is simplified radical form. And everything in yellow is simplified radical form. And again, you're looking at that 14. You cannot simplify it any further. There's no perfect square factor that goes into 14. And that's the reason why. Let's go on to number 11. I am going to leave it in simplified radical form. I am not going to round anymore. Okay, because that's what the directions are saying, and that's what we should do if the directions say. So remember, you always have to get this over to that right hand side. You're adding 14 on both sides. Go ahead, rewrite it, then take B, divide that B by 2, and you'll get your answer, and then square it. Press pause, try this on your own now. So I added 14 on both sides, just like I did over there, and then this is B, so I'm dividing it by 2. 2 divided by 2 equals 1. 1 squared is 1, and I added 1 on both sides. So I put x squared plus 2x plus 1 equals 14 plus 1, which is 15. Now I am looking for binomials that multiply to 1 and that add to 2. Very easy. X plus 1 times x plus 1. So I am going to put x plus 1, and that is all squared. And since that is squared, and you just put down the 15. So you're going to use the inverse operations. Hopefully you did this already when you pressed pause, and we are going to do this like the directions say. So we have x plus 1 equals this plus minus the square root of 15. All right, we are not finished. We have to solve for x. All right, so we have x plus 1 equals plus or minus square root of 15. We are not going to take the square root of 15, round it, put it in the calculator at all. You minus 1 on both sides. You get x equals negative 1, which is right here, negative 1 plus or minus square root of 15. Now, normally you would try to simplify that radical further, but 15 has no factors that have perfect squares. So it's 5 times 3 or 15 times 1, and those are not perfect squares, so it stays x equals negative 1 plus or minus square root of 15. And the last one with completing the square is this one, and right now you know that number 12 is pretty much all set up as far as the C being over here. So go ahead, you could just take a look at B and divide it by 2. That is a negative 0.5, because you realize that that's negative a half, and it's negative 0.5. Then it's negative 0.5, and that is squared. Pretty much will never be a negative number. So negative 0.5 in your calculator is 0.25. All right, so now you would just add that to both sides. All right, you have x squared minus x plus 0.25, adding the 0.25 to the left side, and then adding it to the right side, you have 3.25. So now you have to look for what times what equals 0.25. Since I don't know that, I am going to just take the square root of 0.25 and see if that works out. It's not. Okay, so 0.5. So 0.5 times 0.5, what that does is that it tells you exactly what times what equals 0.25. So it's 0.5 times 0.5. But it has to be a negative to add to to that -1. Right? So it's negative times a negative to make a positive, and negative plus a negative to make that -1. So we are going to put down x minus 0.5 squared equals 3.25. So now, again, with all of these, you're taking the square root and the square root. This cancels, and that's what you get. And then you're adding, remember, you have to actually solve for x. You're adding 0.5 to both sides, and it becomes x equals 0.5 plus or minus square root of 3.25. So that is simplified radical form. You add 0.5 to both sides, you get x equals 0.5 plus or minus square root of 3.25. And that is that for number 12. All right, translate and solve. The square of a positive number minus twice the number is 35. Find that number. So first you have to translate it. Go ahead, see if you could translate it on your own first, doing that first, and we'll come back with the translation. Do not move on after the translation. Just basically do the translation and see if you got that. We'll come back to see if you got it correct. Press pause now. Okay, so we have the square of a positive number. The square of a positive number, so I put n squared, minus twice the number, that same number, minus 2n is 35. So this is why I wanted you to stop, translate first, and then see if it's correct. Press play, and then see if it's correct, and hopefully you did get that correct. Remember, it says translate and solve, so the easiest way, we're going to just do this using the square method, where we're going to take b and we're going to divide it by 2. Sorry. And we're going to get -1. And then we're going to just do -1 squared. And I always put that in parentheses, and -1 squared is 1. So nice and easy, you're going to add 1 to this side, to the left side, and we're going to add 1 to that right side. So we have n squared minus 2n plus 1 equals 36. And now we are looking for two numbers that multiply to 1 and that add to -2. And very easily you have n minus 1 times n minus 1. But I'm not going to put n minus 1 twice. I'm just going to put squared. Equals 36. And as you can tell from there, you're supposed to do what? Use the inverse operation of something squared, and we've been doing this all along. This one works out a little bit easier. I could already tell that the square root of 36 is a perfect square, so I'm going to cancel this out. Just remember, every perfect square, every square root has a positive and negative answer. So you split it up like this, n minus 1 equals 6. You add 1 to both sides here, and you get n equals 7. And 1, and you get 1, and you're adding that, and then you get n equals -5. And those two answers, find the number. They might be talking about the positive or whatever, but we have two roots here. So it's n equals 7 or n equals -5 for number 13. Go ahead, see if you could translate number 14 first, translate it, and we're going to press pause now and then press play after the translation, just to make sure that you are that you have that correct translation before you start and do all the work. Press pause now. Alright, so I remember Miss Gadji and I in class made sure that you wrote down a key, and the key is very important. You could use X or N or whatever variable that you want to do, that you want to use. So you have A equals length times width, where since we're talking about area, the length of a rectangle is 2 feet greater than the width. So I'm starting with the width first as n, or x. And then you have length is n plus 2, because the length is 2 feet greater than the width. So that's x plus 2, or n plus 2. And the area of that rectangle is this. That's why it's important to underline and put down in the key, find the length and width. I have an area formula of length times width. So the way I am going to find this is to actually make an equation up of, and I typed this wrong. This is actually wrong. I am going to put this down as 24. All right, so just make sure that you understand that I made the mistake there with the 24. 242 is not, it's 24. All right, so the area equals, all right, so this is 24 equals length times width. So we're going to have n plus 2 times n. Pretty easy. Now you're going to use distributive property. N times n is n squared. N times 2 is 2n. And I am going to switch this around. This equals 24. I just want it to be over on the right hand side. It's not that big of a deal. You just put it over here. All right. So now I am going to just go ahead and use that solving by square method. So I'm going to put this 2 divided by 2. And that equals 1. And 1 squared equals 1. Remember, you have to divide that b by a 2, and then you square that answer, and then you're adding that on both sides. So I'm going to put that in red. Plus 1 over here on the left side, and remember, plus 1 on that right side. And just like that, n squared plus 2n plus 1 equals 25. So we have n squared plus 2n plus 1 equals 25. You get n plus 1 times n plus 1, because 1 times 1 equals 1, and 1 plus 1 equals 2. All of it's positive, so it's nice and easy, equals 25. So it's n plus 1 squared equals 25. Remember, you use the inverse operation of something squared. You square root both sides. And what's nice about this is that there is a perfect square. So I'm going to put n plus 1 equals 5. Because 5 times 5 equals 25, and n plus 1 equals -5. And so now we minus 1 on both sides here. N equals 4. and n equals -6. So we cannot use, so the only one we could use is 4, because you can't have a negative length or width. You can't have a negative measurement. So this one we are not going to use. We're going to use n as 4. So when we put this in, the width is 4 and the length is 6, because it's 4 plus 2. So just remember that you cannot use a negative length or width at all. So n equals 4 for the width, and the length is 6. And that is it for number 14. Number 15, solve by using the quadratic formula. Just remember, leave in simple radical form, simplified radical form. And we'll go through all of that. But just to get you started, A is 2, remember, and then B is 5, and C is 3. Okay, so we have A is 2, and like we said, B is 5, and C is 3. The quadratic formula, just remember, you have to memorize this, which is negative B plus or minus B squared minus 4AC over 2a, and it's square root of b squared minus 4ac, right underneath here. So now I am going to substitute every number in into my quadratic formula, which is just like you are seeing there, which is -5, because you're talking about a negative b, and the b is 5, plus or minus square root 5 squared minus 4 times a, which is 2, times c, which is 3, all over 2 times a, which is 2 times 2, and you should get this. So you put it directly into your calculator, 5 squared minus 4 times 2 times 3, and that all equals 1. So the square root of 1, the good part about that, 2 times 2 is 4 on the bottom as your denominator. And the good thing about that square root of 1 is that it's 1. That's 1 times 1 is 1. So it's perfect. It comes out -5 plus or minus 1 over 4. And we have, what we have here is -5 plus 1 over 4 is -4 over 4, and that is -1. -5 minus 1 is -6, and -6 over 4 is -1.5. So that's solving by the quadratic formula, leaving in simplified radical form. Remember, square root of 1 was like your perfect square, and those are your 2 roots. Okay, it's showing your work completely. You can check it using your calculator. Go on to number 16. This is number 16, which is right here. You have your A, B, and C. So A is 2. Your B is 1, and your C is -6. Go ahead, use the quadratic formula like we did on the page before. You can press pause now. Alright, so we could substitute this into the quadratic formula. And I mean the quadratic formula right here, which is B, negative b, which is now turns to a -1, plus or minus square root 1 squared, which is b squared, minus 4 times a, which is 2, times c, which is -6. All of this underneath the radical, if you put that into the calculator, you get square root of 49, and then it's 2 times a, which is 2 times 2, and that's 4 as a denominator. Square root of 49 is a perfect square, so it's really nice. Square root of 49 is 7, so remember you have -1 plus or minus 7 over 4. You split up those equations into x equals -1 plus 7, and x equals -1 minus 7 all over 4. 6, negative 1 plus 7 is 6. 6 divided by 4 is 1.5. And then negative 1 minus 7 is negative 8. Negative 8 divided by 4 is negative 2. Those are your roots you solved using the quadratic formula. One last question using the quadratic formula, and we have it here. So your A, just remember your A is the number before the x squared, the coefficient. The B is the negative 2, the coefficient before the x. And the C is your negative 5 without the variable. Go ahead, solve using the quadratic formula. Press pause now. So we have, we're substituting this negative in. We have negative 2 as a B. Negative is positive. So square root negative 2 squared, which is B squared, minus 4 times A, which is 3, times C, which is negative 5. And you square root of 64. When you put this all into the calculator, you get a nice square root of 64, and the denominator is 6. So you have 2 plus or minus 8 over 6. You split up those equations. 2 plus 8 over 6 is 10 over 6, and it's 1.67. X equals 2 minus 8 over 6. Negative 6 over 6 is negative 1. Those are your two roots, and that is number 17. All right. Going on to 18, solve by factoring. All right, so we're going to move away from the quadratic formula for a second. So the first thing that you do, remember, you do have to get this equal to 0. It must be equal to 0. Very difficult to remember all of these methods and everything, but this has to be equal to 0, even if you want to put it in the calculator. Must be equal to 0. So this cancels out, and you have 8x squared plus minus 2x. Almost said plus. And then negative 18 plus 15 is a negative 3. And now it equals 0. Remember, when you're doing this method, you have 8 times 3. Taking A and timesing it, multiplying it by the C in this case, and you're looking for two numbers that multiply to 24 and that add or subtract to negative 2. So we're going to start 1 times 24. No good. 2 times 12. No good. 3 times 8. No good. Almost. 4 times 6. Can you make a 2 out of that? Yes, you can. Can you multiply to a negative? So this is 8 times negative 3. So this would be a negative 24, right? So you can multiply to a negative and add to a negative 2 by making this negative and this positive. All right, so 4 times negative 6. So now we are going to put down, and the way I like to do this is to have 8x squared. Just write it down, 8x squared. Instead of the negative 2x, we are going to put positive 4x. And a negative 6x. You notice that if you do, if you add that 4x and a negative 6x, you will get negative 2x. And then just drop the negative 3 down, all equal to 0. So now you have to factor it. Remember, you have to factor. So we have 8x squared plus 4x. We're going to take the first two terms and factor out the greatest common factor. So let's talk about the numbers first. 4 is the greatest common factor between 8 and 4. And then x is the greatest common factor between x and x squared. So 4x is the whole greatest common factor. So 4x times what equals 8x squared? 4x times 2x. 4 times 2 is 8. X times x is x squared. Plus, what times 4x equals 4x? Well, 8 times 4x times 1. So now you're factoring out a 3 because that's the greatest common factor, and that is it, all right? So that 3 does not have an x. It has to be the same binomial in there if everything is correct. So negative 3 times a positive 1 equals a negative 3. And all of that is equal to 0. Now, when we're talking about making our binomials, you have 4x minus 3 equals 0. Oh, well, I skipped a step. So let me just go a little bit, 4x minus 3 is one binomial, and then the other binomial is, instead of me writing it and butchering it all over the place, I have 4x minus 3 times the 2x plus 1, and now I am ready to split up those, creating two equations. So 4x minus 3 equals 0 is one equation, and 2x plus 1 equals 0. Put a line in the middle if you would like. A lot of people do like that. And then go ahead and solve each for x. And when we solve, you add 3 on both sides. You have 4x equals 3. And then you divide by 4 on both sides. You get x equals 0.75. And then on the right side, 2x plus 1 equals 0. You subtract 1 on both sides. You get 2x equals negative 1. And you divide by 2, you get negative 0.5. And those are the roots solved by factoring. Go on to number 19. It is the same, taking the same steps, remember? It is equal to 0 at this point. So the first thing you should do is 6 times negative 3. When 6, I add the negative later. You're just looking for two numbers that multiply to 18, which it would be a negative 18, because this is a negative 3 and this is a negative 18. You could put that if you want. I do start with 1 times 18 and I'm not worry about the negatives. I know I can't make a 3 if I add those two numbers together. I'm looking for two numbers that multiply to 18 but that add to 3. So I have 2 and 9, and that's not going to work. But I realize, wait a minute, 3 and 6, that does work. So I have to multiply to a negative but add to a positive 3, and the way to multiply to a negative is positive times a negative, and then I put them in later and worry about them. So you have negative 3 plus 6, and that would work both ways. You have, if you multiply those numbers, you get a negative 18, and if you add those numbers, you get a positive 3. So those are your factors. I found them. Yippee. All right, so at this point right now, I am just going to copy down the 6x squared. I just bring it down. All right, see this 3x? I'm just going to add the 6x and minus the 3x. All right, using my factors. And you notice 6x minus 3x equals positive 3x. And then I'm just going to bring that minus 3 down. Once I'm finished with that, I'm just going to take the greatest common factor of the first two terms. And I notice that 6 is the greatest common factor as far as the numbers go. X is the greatest common factor of the variable. So 6x times what equals 6x squared? 6x times x. And 6x times 1 equals 6x. That's pretty easy. So now I'm going to factor out at 3, because that's the greatest common factor. 3 times what? Negative 3 times what equals negative 3x. And negative 3 times what equals negative 3. That is nice and easy. So instead of me butchering these all over again, I am going to make up my binomials as 6x minus 3 and x, and using the binomials in the middle of these parentheses, 6x plus 1, and that equals 0. And you guessed it, that's what you're going to make your two equations from. So we're going to have 6x minus 3 equals 0. And we're going to have x plus 1 equals 0 as well. And again, some people put a line in the middle so that they could separate them. And that's just fine. Go ahead and solve, and I'll solve with you. You're adding 3 on both sides, and I'm sure you're going to be faster than I am because I'm writing on this horrible, horrible screen. 6x equals 3, and then I divide by 6, and you get x equals 0.5. This cancels out. X equals 0.5. I like to leave them in decimals because I know exactly where 0.5 is on that x-axis, where it crosses that x-axis. So you have minus 1 here and minus 1. And this cancels, and then x, I'm going to put it over here, x equals negative 1. And it's an OR. Those are your two roots, solving by factoring. All right, let's do number 20. Oh, write this expression. Write the expression for the discriminant. Use this number to find the real solutions for each equation. So does everybody remember that the right underneath the square root in the quadratic formula, that is called the discriminant. Does everybody remember what that is? Because you should write that down right here. So it is b squared minus 4ac. And actually, I'm not going to put them, you should put them in parentheses, but where it's just 4 times a times c. All right, so if you use the b, the a, and the c, and it comes out to be a number that is greater than 0. Think about it. If you take like in the quadratic formula, if you take the square root of a positive number, that is going to have 2 solutions. But if it's equal to 0, that means it's only going to be touching the x-axis once, not actually intersecting on one side and then going back up and intersecting again, if it's equal to 0. If it's a negative answer, guess what? You have no solution. That's when you have a parabola that is not even close to, well, it might be close, but it's not intersecting the x-axis at all. There's no real answers, no real numbers as far as that goes. No real numbers at all. No solution. So let's just see what everything is. So first off, a equals 2. B is negative 3. This is what I do all the time, because then I could look at this on the side and just figure out what is going on from this list. So b squared is a negative 3. Remember, when you put a negative in, it is so important to have the square, the parentheses around that number when you square it. Because if you put it in the calculator, it's seeing negative 3 squared without any parentheses, it's thinking that it's -3 times 3. But -3 squared says to the calculator, all right, we're taking this whole number inside the parentheses and squaring it. All right, -3 times -3. So -3 times -3 times 4, minus 4 times 2, and in parentheses, just get used to using those parentheses, times 1. So now I am going to bring up the calculator. And you see what I'm doing. I'm putting -3 squared inside the parentheses, exactly like I have it written down, exactly like that, because I don't want to make any mistakes, and I'm making a mistake right there. And that is what we have. Let's press enter, and we get 1. So since that number is greater, than 0, that means it has 2 solutions. This will have 2 solutions using that +1 as an answer. So that is 1. All right, positive number, 2 solutions. Let's go ahead and see if we could do this one. And by the way, this -7 must be over onto that left-hand side. It has to be equal to 0 for you to do this, or to get the true value of what the C is. So I am going to do that with you right now. I have x squared plus 4x and then plus 7. And that all equals 0. So now you could go ahead and put in A as 1, B as 4, and everything is positive, so that's nice, and C as 7. Go ahead, use the B squared minus 4AC, figure it out, and we'll come back with that answer. Press pause now. So I am in the middle of doing this. I have 4 squared minus 4 times 1. I substituted these numbers in, 4 times A, and then times 7, which is your C. You notice I'm not pressing the multiplication symbol on the calculators, because the calculator will know that you want to multiply those numbers. And so now this comes out to be a -12. Negative number. Right? Negative number. What happens with a negative number? Can you take the square root of a negative number? Not that you're doing that. Think about where the discriminant comes over. Where does b squared minus 4ac fall within the quadratic formula? And it is underneath that radical. So if you get a square root of -12, there are no solutions. All right, negative number, no real numbers. You cannot take the square root of that negative, and that's the reason why. All right, so the last one is this one right here, which is number 22, where my face is. All right, so the first thing that you always do is to check to see if it's equal to 0. It is. So you have A equals 1. And you have B equals -6. And C equals 9. This is a rough one, right? No, this is not a rough one. So now you have B squared minus 4 times A times C. Go ahead, substitute it in, see what you get. Press pause one last time right now. Okay, so I substituted the b squared in, and b is a -9, so a -6, so -6 squared, making sure I put it inside parentheses just like I have in my calculator, minus 4 times a, which is 1, times c, which is 9, positive 9. So all of that, I'm going to press enter, and I get a 0. 0. What does that mean? What does that mean? A 0. A 0 means that there is only one solution. 0, 1 solution. And that is that. Just remember, if you go ahead and graph, let me clear this out right away, and clear this out right away. If you go ahead and graph x squared minus 6x, just to check it, plus 9, and you graph it, it should only touch that x-axis once, and it does. All right, so one solution. Remember, two solutions when that number is, the discriminant is greater than 0. No solutions when it is a negative number, the discriminant, and when the discriminant is 0, equal to 0, there's one solution. Hopefully you found this review sheet video, on the review sheet, very helpful. Any questions, please don't hesitate to ask. See you next time.